I'll get it. I'll get it. Okay, how are y'all doing? It's going to be kind of a small class. We had quite a few drops last few days, so we're going to get started here. We have a test on Tuesday, right? This is the review, and I'm going to go through it. And I'm going to go fast because it's a lot to cover. So, y'all ready? Okay. So 1A, remember, we're going to have logarithms on this test. So, yeah. So the first question says to rewrite in exponential form. So do you remember how to do this? Just rewriting. Just use that loop. So you're going to rewrite this using 2 raised to the third equals 8. So 2 raised to the third equals 8. Done. That's it. Okay? Part B, same thing. Log 5 equals x. Uh-oh. 10. Good. So if you don't write the base here, it's understood that it's a 10. So you have to know that to be able to convert it. So this should be 10 raised to the x equals 5. So imagine that there is a 10 here, and then you do the loop. Okay? Part C, natural log y equals 2. Oh, thank you. Same sort of story here. There's no base given, but you have to understand that the natural log has what base? E. E. So this is actually, there's really like an E here, and then you do the loop, and it's really E squared equals y. So we're done with number 1. Any questions there? No? Okay. Pretty straightforward there, right? 2A. Now we're going backwards, right? We're going backwards. We're going to write this in logarithmic form. So to write it in logarithmic form, you need to write this as a log. So we have 4 squared equals 16. Rewritten as a log, you write log, and then what's the base of this log? 4. It's always the base that you see over here. So 4 and then 16 and then equals 2. And then you can double check that you got it right by doing the loop. And if you do the loop and get this back, you did it correctly. We good? Okay, part B. X raised to the y equals 4. So that's going to be written as log what base? X, and then 4 equals y. So these are the answers. You don't have to do anything else. Just write down what's boxed. You're just converting from one form to the other. That's all you're doing here. From either exponential form to logarithmic, that's number 1. Number 2 is logarithmic to exponential. So part C, we have m equals b to the x. So I'm going to rewrite this as log b, right? It's not always the letter that's on the left-hand side. It's the thing that's being raised to a power. So I'm going to write log base b, and then what? M equals x. And again, you can check with the loop that this does give you back the original expression. All right, number 1 and number 2 are down. Number 3, this is where we start solving equations. So for 3, part A, we want to solve the equation log base 3 of x equals 2. So how are you going to solve this? Convert it to exponential form. So use the loop. Rewrite this as 3 raised to the second equals x. 3 to the second power equals x. And that's what? X is 9, right? Just square. 3 squared is 9. So x equals 9. We have solved the equation for x. Part B. Log base x of 10 to the negative 2 equals negative 2. So we'll do the same story. Rewrite this in exponential form. This is going to be x raised to the negative 2 equals 10 raised to the negative 2. So x raised to negative 2 equals 10 raised to the negative 2. Now that looks kind of weird, but just think about this equation. If they're equal, right, and if they both have the same exponent, negative 2, then the bases have to be equal, don't they? So x would have to be 10 here to make these match, wouldn't it? So you don't need to do any other work other than just visually inspect that x is equal to 10. Questions there? Okay, part C. Come on, stay there. Log base 4, x equals 1/2. So we'll just do the same thing we've been doing. We're just going to do the loop. It's going to be 4 raised to the half equals x. 4 raised to the half equals x. And now you need to remember what it means to raise something to the half. What does that mean? What does this really mean? Not divided. No.
1 over 4 to the power of 2.
1 over 4. That's if it was negative. If it was negative 2, you would do 1 over 4.
Is it that square root?
Square root, good. So just remember this. If you have x, anything raised to the 1 over n, this is the same as the nth root of x. So this is x to the 1/2. Sorry, not x. This is 4 to the 1/2. This means the square root of 4, right? Now we normally don't write the 2. Are you all following me? Okay, equals x. And what's the square root of 4? 2. So x is 2. Let me give you another one of those, just to make sure we're on the same page here. What if we had log base 8 of x equals 2/3? So you would do the loop like this. 8 to the 2/3 equals x. And what does that mean to take 8 and raise it to the 2/3? So this formula actually does not, it works for that, but not completely, because this formula always has a 1 up top, doesn't it? Right? So we have another formula if this fraction is not 1 over n. It's like this. If we have m over n, then it's the nth root of x to the m. Or you could write the nth root of x, all of that to the m. The way that I remember this is that whatever the denominator is going to be the root you're taking. And the numerator is the power on this thing. So for this right here, I'm going to be taking the cube root of 8, and then I'm going to be squaring that answer. Understand? So what is the cube root of 8? The cube root of 8, I'm going to figure out what that is, then I'm going to square it. That's x. So cube root of 8 you said was 2? That is correct, because 2 times 2 times 2 is 8. And then we have to square it, so 2 squared is 4. So your answer is 4. That makes sense? This comes into play again in a little while. That's why I want to make sure that you're comfortable with that. Okay, no questions? Let's move on to number 4.
Wait.
What? Oh, wait, keep it? Okay. You want me to rewrite the problem or just leave this? Okay.
As far as the exponent being negative, taking the reciprocal, that can you give an example of that?
You want me to do an example of a negative exponent? Okay.
Where you have to put it over one.
Yeah, what if we had log base 5 x equals negative 2? Something like that. So this means, according to the loop, you'd have 5 to the negative 2 is x, right? So write down 5 to the negative 2 equals x. Is this kind of what you're talking about? Okay, so now we have a negative exponent. You need to remember this property, that anything raised to the negative n is equal to 1 over that to the positive n. So if you have a negative exponent, you can drop it down like a fraction and change the exponent to positive. So we have 5 to the negative 2. This should become 1 over 5 to the positive 2. So this should become 1 over 5 to the positive 2. And what is 5 squared? 25. So this is 1/25. 1 over 25. That's what x would be. Does that help? Yeah?
Sir, how would I do the cube root on this calculator?
How do you do the cube root on a calculator? Anyone know how to do the cube root on a calculator? You're going to use, okay, so let's say we want to do the cube root of 8, all right, on a calculator. I think, yeah, you can use that, but there's a shorter way. You need to be comfortable with the idea that that's 8 to the 1/3. Okay, right? That's what that means. Then on your calculator, do 8. Then on your calculator, because I can see it, you do the little caret key. Okay, and then you do, very important, parentheses, 1 divided by 3, close parentheses, and it'll spit out 2. Got it? Just, if you forget the parentheses, though, it's gonna give you the wrong answer, okay? You can do that for any power. So if you want to do the 5th root, you do, whatever raised to the 1 divided by 5. If you want to do 2/3, remember how we did 2/3 here? 8 to the 2/3, you go 8 raised to the 2 divided by 3, and it should spit out 4.
Got it.
Okay?
What if it's a negative?
Fraction?
Yeah.
Okay, I can do that. The question is, what if it's a negative fraction? Do you want me to just show you how to do it or do a problem with it? I'll just do a problem.
Are you fine if it's on the test just using our calculator and putting out a decimal answer?
This is business math, so yeah, I'm okay with that. Yeah. Trying to think of a good number here to work with. Let's go 25 x equals negative 3 halves. Log base 25 of x equals negative 3 halves. So you create your loop. Our loop would be 25 raised to what power? Negative 3 halves, right? Equals x. Now this is kind of like the ultimate problem because it has a combination of both a negative exponent and a fraction, right? And that fraction doesn't have a 1 up there, it's 3 halves. So you can kind of attack this different ways, but let me see if I write this, if this makes sense. So I'm just using the property that if I have a negative exponent, I can take this whole thing and drop it down, right? And make it a positive exponent underneath the 1. So that's okay? Now, 25 to the 3 halves, that is the same as the square root of 25, what? To the 3rd power. And of course, you could do this on your calculator now, too. You would type in 25 caret parentheses 3 divided by 2, close parentheses. What is the square root of 25? 5. So this is really 1 over 5 cubed is x. And then 5 cubed is 125. See, if you use your calculator, though, you're going to get a decimal answer. If you don't use your calculator, you're going to get a nice fraction like this. So, I won't care, but, if this were more of a math course, like a pre-cal or something, we do not want to use our calculator for something like this. All right, we good? That kind of clear up any issues? All right, good. All right, let's move on to number 4. So for number 4, we're going to solve some equations. Part A, log base b of x equals 2/3 log base b of 8 plus 1/2 log base b of 9 minus log base b of 6. Okay, what is the base of this log right here?
10.
B, right? What's the base of this log? B, B, B. Since they all have the same base, we are allowed to use those properties of logarithms. There was like 5 or 6 properties of logarithms. So what I'm going to try and do first is clean up this right side. I notice I have addition and subtraction between logs, and that means I can put them together into a single log. Before I do that, however, I need to resolve the number that's out in front. So I have a 2/3 out here, I have a 1/2 out here, and I really don't have a number out here, just I have a 1. So do you remember what we do with these numbers? Push them up as powers on these numbers. So we're using one of the properties of logs, that if you have a power out here, it can come out front. We're doing the reverse of that. We're taking the number out front and pushing it up as a power. So we're going to first write log base bx equals log base b 8 to the 2/3 plus log base b of 9 to the 1/2, and then minus log base b of 6. So all I've done is push those powers, those numbers in front up as powers. Now 8 to the 2/3, we just did this, didn't we? 8 to the 2/3 is really what? 4? And this means the square root of 9, which is 3. Okay, so this step, I'm just doing a little bit of arithmetic on those numbers. This was 4 log base b of 3 minus log base b of 6. Okay, at this point, at the point that I have 1s in front of each of these, right? Those are 1s in front. Now I can start putting them together into logs. So if you have 2 logarithms that have addition between them, you can turn this into a single logarithm. And what happens to the 4 and the 3? We multiply them. 4 times 3. Do you want me to write the properties on the board again, or are you comfortable out of your notes?
Are we allowed to, on our formula sheet, write the properties?
Man. Are we doing formula sheets? Yeah. I'll let you do a formula sheet. But I'm just going to warn you, if you move on, you do the next Math 1325, I can't guarantee that the professor's going to let you have formula sheets. If you take me, I can't guarantee that either. But, I'm trying to help you all get through this and do well, but you can't, you can't depend on a formula sheet every single time in math. I mean, there are things you just have to learn and memorize, and these formulas, I know there's 5 of them or 6 of them, but yeah. Okay, so I'll say you can have a little formula sheet, all right? Regular sheet of paper, front and back. No worked out problems though, just formulas. All the properties, yeah. And then you can have your future value, present value, PERT, all those formulas, yeah, you can have those, okay? That'll be my Thanksgiving gift to you. Y'all got like a Halloween gift and a Thanksgiving gift, huh? And then the final's near Christmas, so you have a Christmas gift? Okay, so what am I going to get here? Log base b of what? 12. And then I still have minus log base b of 6. So I still have 2 logarithms on the right-hand side. So I'm going to try and put those together. This time I have subtraction. When you have subtraction, it turns into 1 log, this time division. And what is it, 12 divided by 6 or 6 divided by 12? Because that's 2 different answers. It's this divided by this. Okay, so 12 divided by 6 is 2. So log base b of x equals log base b of 2. And now we finally have it down to a place where if you look at it, the left side and right side are almost identical, aren't they? Yeah, you just need whatever's in here to match whatever's here. So x has to be 2 for this to be true. So x is 2. All right, so stepping back and looking at this problem again from the beginning, you had a log on the left and a bunch of logs on the right. You say to yourself, okay, I'm going to try and make the left log look like the right log. So I'm going to have to put all these logs together into a single log. You work your way through that, you get it down to a single log, and then it's just matched the left and right hand sides. That is different than the next problem. 5b, uh, 4b, sorry. 4b, you have log base 10 of x plus 6 minus log base 10 of x minus 3 equals 1. Notice on this equation, you don't have a log on the right-hand side, do you? So you don't have logs on the left and logs on the right. So you're not going to be playing this matching game anymore, trying to get it to look like this. See the difference? But you still can, on the left side, put those 2 logs into 1. So let's put those 2 logs into 1. I have subtraction, which means I'm going to create division, right? So my new log is going to be log base 10. And then what divided by what? X plus 6 divided by x minus 3. And I'm just going to put that in parentheses. Okay, this is the argument of the log function. This is the thing that's getting plugged into the log. And then all that needs to equal what? 1. So you can't match the left and right hand sides anymore. So here's a critical step of the problem. What do? You want to try and get these x's out of this log, right?
Multiply out the x minus 3. Amount?
Can't multiply both sides by x minus 3 because this is trapped inside of this log. I mean, the logarithm is almost a problem right now, right? Because this stuff I'm trying to solve for is trapped in it. Maybe I shouldn't look at it in logarithmic form. Maybe I should convert this to exponential form. What would happen if I changed this to exponential form? What would it look like? 10 raised to the first power equals this, right? And then there's no more logarithm in that equation. So I'm going to write that down. So we're basically at this point using the loop. We did not use the loop at all in part A, right? Not at all. So my next line should read 10 raised to the first power equals x plus 6 over x minus 3. Be careful. This is not 10 times 1, right? It's 10 raised to the 1. So if that was a 2, this would be 10 squared. If that was 3, 10 cubed. Big mistake I see is, let's say that was a 2. Students will put here 20 equals this. That's wrong. It's 10 squared, which is 100, right? So just remember that it's exponential, not multiplication. Okay, so the left side of this, 10 to the first power is just 10. And the right side's x plus 6 over x minus 3. Now you can multiply both sides by x minus 3. Now you can do that because there's no logarithm in the way anymore. So I'm going to multiply both sides by x minus 3. And why am I doing that? It cancels the denominator on the right-hand side. Cancels out the x minus 3. What I'm doing here is I'm clearing the fractions. And on the left side, when I multiply x minus 3 times 10, I must distribute that 10 to both the x and the negative 3. So what's my left side going to be? 10x minus 30. And my right side, what's here? X plus 6. All right, now we have reduced this thing down to a linear equation. We just get all our x's on one side, all of our numbers on the other side. So how about subtracting a single x on both sides? And at the same time, let's add 30 to both sides. And we should get, how many x's on the left? 9x equals 36. And divide by 9, you get x is 4. And on the test, I give you 9 out of 10 points here. You've got 90% on this problem if you do that. How do you get that extra 10%? Check your answer. Remember with logarithms, you always need to check your answers. When you're solving a logarithmic equation, you have to make sure this answer works. So what you do is you take that 4 and you come back in here and you plug it in. And what we need is that when I plug it in right here, I cannot have 0 or a negative number. It must be positive. So is 4 plus 6 positive? Yes. Is 4 minus 3 positive? Yes. This answer works. That's all you have to do. It's a visual inspection. Okay? So I don't even know how I would grade that. The only way that that would catch up to you is if let's say you didn't check it, but it didn't work, right? Then you might have an answer even though that's not the answer. So what if this didn't work? What would I say? What would I say? I mean, like if you were taking the test and you check this and it didn't work. Like let's say this was x minus 5.
No solution.
Then you would say no solution. There's a problem like that in your homework. Okay, questions here? Let's look at 4C. Does anyone see the main difference between 4B and 4C? Yeah, you have addition between these two logs instead of subtraction. And you still have the same format that you have logs on the left and then you don't have any logs on the right. So you're not trying to match things up like in part A. So you combine these two together. When you have two logs being added, what happens to these pieces? What do you do with these two things? You multiply them, right? We're going to have to multiply them instead of divide. So this can become log base 4. And then watch what I put here. I'm going to take x plus 2 and multiply times x minus 10. And that must equal 3. So I've given myself some room here to write down this one and this one. And then on my next step, I'm actually going to multiply this out. Although I don't have to multiply this at this point. I can wait. What can I do next before I multiply those together? Do the loop, right? Let's get this out of logarithmic form. Hey, why couldn't we just do the loop at the beginning? Like just loop it now. The reason is because you can only use the loop if you have a single log. And here we have 2 logs, right? The loop only works if you have 1 log. Then you can do this thing. Okay, so that's why we have to put it together first. All right, so what should my next line read? 4 raised to the 3rd power, right? 4 raised to the 3rd power must be equal to x plus 2 times x minus 10. And what is 4 raised to the 3rd power? 12? No. That's 4 times 3, right? That's 4 times 4 is 16 times 4, 64. Left side 64. And then the right side, let me go ahead and multiply this. X squared minus 10x plus 2x minus 20. So I'm doing just like a FOIL on the right-hand side. And then I'm going to collect all my like terms together. So 64 equals x squared minus 8x minus 20. What type of equation do I have? It's a quadratic equation. So to solve this, I need to move everything to one side. So how about we subtract 64 from both sides? And then what will my new equation be if I subtract 64 from both sides? 0 equals, right? X squared minus 8x, and then what? Minus 84? Right? Now, just FYI, okay, just so you know, when you have an equation like this, it does not matter which way you write it. Like I can write the 0 on the left or the 0 on the right. It's the same equation, all right? How do I solve that? What are my options? I can try and factor it, and if I can't factor it, quadratic formula. So I would put the quadratic formula on your formula sheet just to have it, just in case. But I think this one factors. 14 and 6. So this is the way we do that. You multiply the number in front, which is 1, times negative 84. Then you take the number in the middle, negative 8. You're trying to come up with two numbers that multiply to be negative 84 and add up to be negative 8. And you said what? Negative 14 and 6. So if you multiply these two together, you get this. And if you add these two, you get this. So works out. So that means this should factor to be x minus 14 and x plus 6. And now you set each of those to 0. So if I set this equal to 0, what's my solution? X is positive 14. If I set this to 0, I get x is negative 6. So I would have this. That's 9 out of 10 points. Because you have to check it. Now, I've erased the original equation. But one of the logs had x plus 2 in it, right? Yes. Would this work if I put 14 plus 2? Yeah, that'd work. What if I put negative 6 plus 2? That'd be negative 4. That's not going to work, right? And then the other one had x, what was it? A minus 10? Okay, will this work if I put in x minus 10? Yes. This one already didn't work. I should have canceled this one out. But this works in both of them. So this is our only solution. Make sense? So would you agree with me at this point that number 1, number 2, and number 3 are relatively straightforward? But number 4, you know, you're going to have the possibility here of solving a quadratic equation, or on part B, you had to solve a rational equation. We had to multiply both sides by something, like x minus 3 to clear the fraction. So 4 has a little bit more meat on the bones, I guess, right? Let's look at number 5. Solving more equations, but these equations are exponential equations, not logarithmic equations. So 5a, we want to solve 5 to the x equals 8. So that's not something you're just going to know off the top of your head, right? Like 5 to the 1 point something is 8. You don't know that number, do you? So the way we solve this is first to rewrite it in logarithmic form. All right? So let's rewrite this in logarithmic form. When we do that, we get log base 5, 8 equals x. Now, on the left side, you have a log base 5 of 8, and you do not have a log base 5 key on your calculator. However, I gave you that very important formula we call the change of base formula. And I don't recall how I wrote it on the board, but this is the formula. Do you have it written there? Did I use x and b? I used m and b. Okay, sorry, I used m and b because I think I was trying to follow the book. Okay, so this was the very important formula that I said, this is why your calculator only really needs a natural log key, because if you have the natural log key, you can do any logarithm. So that means I'm going to take that and I'm going to convert the left side over to natural log of 8 divided by natural log of 5. And that will be what x is. Now, be careful. We are not doing natural log of 8 divided by 5. That is not what we are doing. All right? And on your calculator, you're going to have to do 2 natural logs. So why don't you make sure that you can do that and get the correct answer. That way, on Tuesday, you're not like trying to learn this for the first time. So natural log 8 divided by natural log 5. 1.292. Okay. Does anybody need help with their calculator at this point? Does anybody not have a calculator? Who doesn't? Did you not have one? Here.
My phone's got one, remember?
Yeah, but I can't let you use your phone. But this is the same calculator you have on your phone. I want that back after the test, please. Go and practice with it this weekend. I have another. I have like a stack of these calculators in my office. Because like every semester, somebody loses a calculator. And they never come back for it. So, got a bunch of them. All right. If you get an A on the test, I'll give you that. You can have the calculator.
For real?
For real. All right. I don't know if I can make that deal for everyone though. Hold on, that's not fair, is it? Who doesn't own a calculator? All right. If you get an A on the test, we'll talk. All right. Maybe there's something I can do for you. I can't give you money, but I can give you a calculator maybe. Okay. All right. 5B. By the way, does that answer make sense? 5. Our original problem was 5 to the x was 8, right? And what did we say x was? 1.292?
Yeah.
Okay, so our answer is 1.292. What would 5 to the first power be? 5? That's not big enough. 5 squared? 25. 2's too big, right? So the answer should be between 1 and 2, which it was. That's just a way to make sure, like, does my answer make sense? Like, if you would have got x is like 10.6, something's wrong, right? Is there a question? Yeah. Uh-huh. On the test, decimal-wise, for these problems, 2, 3 decimals. Decimals become important when we start doing the future value, present value, but even then, 4 decimal places. I'm going to be more interested in seeing your work and making sure you're doing it correctly. So even if you don't do enough decimals, I'll be able to see that you know what you're doing. Okay, 12 to the x equals 150. These are all pretty much the same problems, except C is a little different. So I'm going to first do what here? Okay, now before we do it, can you think of maybe like what that answer should be, like close to?
12. 13, 2, 12 squared. Between 1 and 2?
12 squared, 12 times 12 is 144, isn't it? So 2 would be not quite enough. 3 would be way too much, right? 12 times 12 times 12 would be way over 150. So the answer should be bigger than 2, but close to 2. Let's see. Rewrite this in log form. Log base 12, 150 equals x, right? And then if I rewrite that, using the change of base form, that's natural log 150 over natural log 12 is x. And what do you get there? 2.016? That's a 2 up front. That's a pretty terrible 2. I'm not even sure what that looks like. A terrible 2. We good? Okay, part C. E to the x equals 4.5. All right, if I rewrite this using logarithmic form, it's going to be log base what? E of what? 4.5 equals x. Now, you can use the change of base formula again, right? Same thing we've been doing. However, what is log base E? What is that really? That's the natural log, isn't it? So this is the same as saying natural log of 4.5. Just straight up, you don't have to do any division here. And that should be your answer. Should be like 1 point something. What is it? 1.5 something? Now, had you done this, I'm thinking you might have a hard time typing this into your calculator. Maybe, maybe not. Try it. See if you can type in natural log of e. You should get 1. Who's not getting 1? It's okay if you're not. That's why I'm bringing it up. Yeah, but I'm just saying this part right here, natural log of e by itself, just if you do that, make sure you can get 1 there. But remember, you don't have to do this, right? You can just go straight to this. Because it's base e, you can go straight to this. All right, let's move on. Word problems. Everything's a word problem from here on out. Number 6. How long will it take to grow $4,000 to $7,000 if money is invested at 3.5% with interest compounded 2 different ways, quarterly and continuously? So for number 6, part A, all we're doing in this problem is we're putting money into the bank, $4,000. We're asking how long is it going to take for that to grow to $7,000. Are we adding money each month or each week or anything like that? We are not. So this is just simple interest. Which simple interest formula will part A be? A equals P parentheses 1 plus R over N to the NT. How do you know it's that formula? Because it's quarterly. And while we're talking about part B, what formula are we going to use? PERT, right? I do have PERT shampoo at the house. I always have to have that. Yes, it's just the math part of me, I guess, always needs to have PERT in the house.
You always have pie?
Yes, we do. We always have a pie. Even if it's like moldy and stale, we just keep pie in the house. All right, so part B is continuously. That means it's that formula. Part A is quarterly. That means there's an N in the problem, right? But the important thing is that you understand that both these problems are simple interest because we're not adding money regularly, right? We're not making regular payments, and we're not taking money out regularly. That takes us into the other 2 formulas for future value and present value. All right, let's identify some things here. For this one, do we know what P is? P is the amount that we're going to put in the beginning, right? 4,000. Do we know the interest rate? What is the interest rate? 0.0325. Got to use all those decimals. Okay, do we know what N is? That's the number of times it's compounded per year. So quarterly means 4, doesn't it? Quarterly? Good? Good? Okay. And then do we know what T is? No, but look at the first 3 words or 4 words, 5 words. How long will it take, right? That means we want this, don't we? What's the only thing we have not used? The 7,000, right? That's the amount that we want at the end. So we actually know what A is. A is 7,000. We're going to start with 4,000 at this interest rate, compounded quarterly, and we want it to turn into 7,000, and we want to know how much time that's going to take. Here's the formula for that. So now we just plug everything in. A is 7,000 equals 4,000, that's P, parentheses 1 plus 0.00325 divided by 4 raised to the 4 times T. A, P, R, N, N, T. And we are solving for what? We are solving for T. We need to solve for T. Look at the problem we did a second ago. 5 to the x equals 8. We were solving for x, weren't we? And x was up here in the exponent, and we had to turn this into a logarithm to do it. Same thing here. If we're going to solve for t, we have to turn this into a logarithm. However, we got to do some other stuff first. So let's start cleaning up some things. What do you have to do Or what can we do at this point?
Add the one.
You want to go ahead and put these together? Figure out what that is? I don't mind doing that. Take 0.0325 divided by 4, and then add 1 to that. And that way we'll get everything that's in that parentheses. Do you get 1.08125? Yes. Okay. So we have 7,000 equals 4,000. And then this in parentheses is 1.008125. Do not round that to 1.008. Take as many as you can here. And then raise to the 4t, right? 4t, yes. 4 times t. Now, we're almost to this point. This says like you have a base to a power equals a number. I kind of have that. A base to a power equals a number, but I've got this 4,000 here. And that, is the 4,000 being raised to the 4t? No, it's not. Can I multiply 4,000 times this? Can I do this operation? I'm showing you what people do that's not correct. So this times this. Why can't I do this multiplied times this? Because order of operations always tells us you have to go do exponents first. So I need to know what t is so I can do this, and then I can do the 4,000. So I'm not allowed to multiply the 4,000 here. So the only way to really get rid of that 4,000 right now is to divide it on both sides. So divide 4,000 here and divide 4,000 here. So we take 7,000 divided by 4,000, 1.75. Bless you. I'm going to continue this right here. So the left side now is 1.75 equals parentheses 1.008125 raised to the 4 times t. Now that looks like 5 raised to the x equals 8. Do y'all see that? Number raised to power equals number. Now rewrite this in logarithmic form. It's going to be log, what base is that? It's a weird base, isn't it? 1.008125. That's the base. 1.008125. What goes inside the logarithm? 1.75. And then equals what? 4t. Just double check it with the loop. This raised to this equals this. That's the original equation. Now, how are you going to handle the left side? What are you going to do on that left side? The change of base, the ln over ln. Okay, so take your natural log of 1.75 and divide that by natural log of 1.008125. And that will be 4 times t, won't it? 4 times t. So natural log 1.75 divided by natural log, oops. Whoa, what did I do? Okay, natural log of 1.008125. I'm getting on the left side 69.155. So 69.155 is equal to 4t. And finally, to get t, you divide by 4. What do we get in 17.2, 17.3? Now, I'm rounding it now because what is this answer? T is measured here in what units? Years. Years. You got $4,000 sitting around. You stick that in the bank at 3.125%, and you let it sit there, you don't touch it, then it will take 17.3 years for it to grow to $7,000. if it's compounded quarterly. Now for part B, we're going to do the same setup, right? Same exact setup. A is 7,000. P is 4,000. R is 0.03125. But we don't have an n this time. With continuously, there's no n. So 7,000 equals 4,000. E to the 0.031, was it? 31? 0325, not 125. Okay. T. Now for this one, we have e raised to this power, and we could try and do the loop, but again, the 4,000 is an issue, right? The 4,000. So let's get rid of it. Divide both sides by 4,000. And when we did that before, it was 1.75, right? Now what? Yeah, do log form, so do the loop. So my loop is going to be log base what? What's the base of the log? E. And then what goes inside the log? 1.75. And what's on the other side? Equals what? 0.0325t. Double check it. E raised to this power is 1.75, right? Sure? Okay. You know how to get to the videos for the class? Yeah. Okay, just make sure, because we worked through the first 5. We're finishing up the 6th one right now. Okay, so no questions here? What about this? You can just do natural log. So you don't have to do the breaking it up into 2 logs because it's base E. Over there we had to. Here we don't. So this is just natural log of 1.75, which I'll do on my calculator. The left side I get 0.55962 or something like that. I'm going to leave that answer up there. So I have 0.55962 equals the right side 0.0325t. Okay, quick little guess here. If our interest was compounded quarterly, it took 17.3 years, right? If it's compounded continuously, do you think it's going to take more time to build up to 7,000 or less time? Less? Let's see how much less. It shouldn't be much, but it should be a little less. So take that number, divide both sides by 0.0325. Oh, it's about the same thing. Did we round? We rounded the other one, right? This one comes out to be about 17.21 or 22 or something like that equals t. So you're still waiting 17 years for this to happen. Slight difference. Yes?
How did you get the 0.559?
Okay, so this right here, remember, this just means natural log of 1.75. Because it's base E, log base E really means natural log. So you do not have to do the ln of 1.75 over natural log E, although you could, right? Because it's natural log of this number over natural log of the base. If you do that on your calculator, you should still get 0.55962. Is that clear?
Yeah.
But you do see how in the previous problem you couldn't do this because it wasn't base E. All right. That's why this formula is preferred, because this part right here is a lot easier to compute. All right, let's see now. We are moving on to number 7. How are we doing on time here? 10:24, got 20 minutes. You deposit $200 every month into an account at 4.125% compounded weekly. How much is there after 5 years? All right, this is future value because you're starting with nothing, right? And you're putting money in. So you want to know the value of this in the future. The future value formula that you are allowed to have a cheat sheet, sir, on the test. You can have a little formula sheet, no worked out problems. So make sure you put all the formulas there. I would definitely put this one here. Payment times 1 plus I to the n minus 1 over I. That's the formula we need for this one. You have to recognize these problems. I may not give you these problems in this order. So I might scramble the word problems so that the first one's not necessarily simple interest. All right? So be prepared for having to identify what formula goes with what problem. All right, so what do we know about this? What pieces do we know? Do we know the payment? 200. We're putting in 200 a week, aren't we? Okay, do we know the interest rate? It's 4.125%, but how often is it compounded? Weekly. So we take 0.04125 and we divide it by however many weeks there are in 1 year. So 52 weeks in a year. This is going to be a very small number. I'm getting something like 0.0079327, something like that. Now, is anyone on their calculator getting 7.93269 something, and then at the very end it says E negative 4?
Yeah.
Okay, what this means is you got to take that decimal place, you got to move it 4 places to the left. 1, 2, 3, 4 right there, which puts 3 zeros in front of that 7. That's where I got that number. We good? Okay. Now you want to go out, you do not want to round this to 0.007. I would go out like at least 4 numbers after the zeros. Yes?
How do you get all those numbers on loss?
Okay, like where did I get this number from?
Yeah.
What's our interest rate in the problem?
Okay, I see that.
4 point, okay, converted. And then how often is that interest compounded?
5 years.
No, look at right after the 4.125, it says it's compounded weekly, right? Weekly, we have to look at how many weeks there are in the year. And so we use 52. So if it would have said compounded monthly, you would have used 12, quarterly 4, right? So it's important that the I, this information comes from the interest rate divided by how often it's computed, not how often you're putting money into the bank, okay? All right, we good?
Yeah.
Okay, now what else? Do we know what N is? N is the total number of payments that you're going to make, total number of deposits, total over the entire period of the loan, or not the loan, the savings in this case. So you're doing monthly payments, aren't you? It says that right up there. You deposit $200 every month. So you're going to take 12 months, and how long are you doing this for? 5 years times 5. So 60. N is 60. That clear? What you don't want to do is confuse the 12 months here, right, with the how often it's compounded. Like you don't want to put 12 here, that would be incorrect. You don't want to put 52 here. You got to get these two numbers right. All right, and then the only other thing here is future value, and that is actually what we're solving for. So let's try this. We have future value should equal 200 times, then a big old fraction. We have, what is 1 plus I? What's 1 plus this? It's just 1.0007937. So I'm going to write that down. 1.0007937 raised to what power?